Hey, thought I'd try to do another algebra problem today. We have this equation on the board. We have 625 to the sine squared x plus 625 cosine squared x equals 130. And we're going to want to solve for x, but we're given a range, and we're given this range for x over here on the right for our solution. Now, the first thing I notice is having trig functions in the exponent seems kind of tricky, but what I want to do is kind of try to transform that. So I'm going to use this identity cosine squared x equals 1 minus sine squared x, and so I'll use that to rewrite this exponent. But then from here, by exponent properties, I'm just going to rewrite this term. We'll write it as 625 over, because we have the minus sign, we can write this as 625 sine squared x in the denominator. And then doing it this way, we have this term in common. This is the same. We have 625 sine squared x. And what I'm going to do then is make a substitution. I'm going to call this equal to y. So then we'll rewrite this in terms of y. So we'll have y. So we're going to have y plus 625 over y equals 130. But then I don't really like a y in the denominator here. So what I'll do is multiply both sides by y. This is going to transform to y squared plus 625 equals 130y. I want to get all my terms on the left side, so we're going to write this as y squared minus 130y plus 625 equals 0. Now we've got a quadratic. At this point, I'd like to factor this, and what I want to notice, 625 can be written, 625 is the same thing as 5 to the 4th. Now we could use the quadratic formula on this, but I'm just going to kind of factor it on the fly. So let's kind of write this out. We're going to have y's here. Because this is a plus, we'll have two minus terms. We need two things that are going to multiply together are going to equal 625. Well, I'm taking a guess that our factorization is going to be in the integers. We could do this only a couple ways. We could do this as 5 squared times 5 squared, so 25, 25. But when we do that, we're not going to get 130. The way this is going to work is if we do 5 cubed, which is 125, and we put a 5 here. So what we find is our two roots of this quadratic are going to be 5 and 125. So first what I'm going to do is let's just focus on our 5. So we're saying 5 is going to be equal to 625 to the sine squared x. Now our 5 is just to the 1 power, but as we said before, 625 can be written as 5 to the 4th. And then by exponent properties, if I just multiply this in, we can write this as 5 to the 4 sine squared x. At this point, because we have the same base, we can equate the exponents. So doing that, we'll see that 1 equals 4 sine squared x. So then sine squared x equals 1 over 4. And so sine of x is going to be just plus or minus 1/2. Now solving for x, we could find the arcsine of plus 1/2 or minus 1/2. And there's going to be an infinite number of values for that. But the arcsine of 1/2 is going to be at pi over 6. But we have a bunch of other solutions. We have 5 pi over 6 and minus pi over 6. But the thing is, we have this range here, which is going to eliminate all these other solutions. We'll throw out these other solutions because they're not in this range. Okay, so now that we have one solution, we'll focus on this second value of y, 125. But what I'm going to do is let's take 125 and we'll write that as 5 cubed, and we'll equate 5 cubed to 625, and I'm going to write that as 5 to the 4th sine squared x. But again, the same thing we did before, we'll write this as 5 to the 4 sine squared x. Same base, so we'll equate the exponents. So we're saying 3 equals 4 sine squared x. Then sine squared x is going to be 3/4. We'll take a square root on both sides, and we find our sine of x is going to be plus or minus square root of 3 over 2. But again, we can look at this as x equals arcsine of plus or minus square root of 3 over 2. And this is going to happen at pi over 3, 2 pi over 3, minus pi over 3, etc., etc. Again, a whole bunch of solutions. But again, we're only interested in the solution between 0 and pi over 2, so we can get rid of all this, and we have our second solution, pi over 3. So we'll end up with two solutions for this. We're going to have x equal to pi over 6 and x equals pi over 3. Okay, that's it. We'll stop it there. Thanks everyone for watching. Have a great day.